guys, once again, we're going to be going to a new presentation as regards implementing a simple fire alarm system. All right, so we'll be doing the first version of this presentation, and then it will follow by a second version. All right, so we're going to approach this one with the most simple and basic information regarding fire alarm system, and then we're going to step it up a notch by showing you a little more advanced aspect of how the system is designed and implemented. All right, so this presentation was brought to you by Visual Society of Engineers. Now, first, for a fire alarm system, we have two major components, and that include an initiating device and a notification device. All right, so within indication or initiating devices, we have the carbon monoxide detectors. We have something like an electric or a photoelectric detector, manual call point, and pulsation. On the notification side, we may have speakers, strobes, bell, siren, and telephones. All right. So next, I'm going to show you a vivid illustration of these components. All right. So these are the most common components that is used, and that includes a smoke detector, pulsation, and a speaker strobe. If you're accustomed to seeing a fire alarm system, these are the major components you will be able to identify. All right. So the smoke devices detect carbon monoxide, all right, or any smoke which disperse within the air. And the pulsation is manually activated. Strobe provide indication that the signal is picked up by the whole by the fire alarm system rather, and it is being activated. All right, so with the fire alarm system, there's two types of configuration for wiring. All right, so we have the Class A configuration and we have Class B configuration. The most reliable of the two is a Class A configuration. In the Class A configuration, it requires a loop in and a loop out configuration for the fire alarm when we are setting up or initiating device or a notification device. All right, so a loop is terminated across an input terminal, A plus or A minus terminal. All right, so basically we create this loop for consistency to ensure that power is stabilized across the devices. All right, so a closed loop ensure that we have reliable power source between the devices. All right, and then we have rather we do not utilize the EOL for a Class A, because what the EOL does is to ensure that the loop actually closed, and it would have been closed by the closed loop. All right, so when you have a loop closing on the first and the second terminal of the fire alarm system, then it reduces the need of a EOL resistor. All right, and then we have a Class B configuration. So Class B systems are required for simple wiring method. All right, so Class B system does not provide a reliable power source or device should a fault occur on the network. All right, so if you lose power on one side of your network, then the Class B will simply fail. All right, because it does not provide a closed loop power source to ensure that power is provided on both ends of the same loop. All right, and the Class B configuration doesn't require a return loop, then it has to be terminated with a EOL resistor, right? So the fire alarm system is such that it has to be closed in order for it to ascertain that there's been no tampering on the circuit, right? So every fire alarm system has to happen to have a end of line resistor, or when we utilize a Class A configuration, then it is closed between the inputs of the SLC circuit, right? So we have to ensure the terminals for the loops is terminated on two, select line current circuit, right? Now, next thing we're going to look at is the wiring configuration in its physical layout, right? So when we talk about the Class A network, look at the notification device where the circuit is feed from one device to another, then return back to the panel, right? And then we have the same configuration layout for the notification devices, where the loop is taken from one device and to another, then it goes back to the panel, all right? So there's multiple output for the notification devices, and there's multiple input for the notification devices. So we'll utilize two of those outputs or inputs rather for the notification or the initiating device, right? So within the Class B network, we're going to always terminate with a end of line resistor, right? And it is just a simple loop of one device to another, all right? And then that does not require a looping back to the panel. So in the Class B configuration, however, you can use more devices, but again, it may not be as, you know, rather safe in terms of its operation, and does not provide much um, reliable ability while it is utilized within the building once a fire should occur, right? So the whole purpose is to increase the reliability of the power source on the network of the device. The fire alarm modules. Now, with the fire alarm modules, it's basically like a initiating device. In some cases, it can use as a output, right, for the network. So you can use module for adding more, they call initiating devices and output device or notification devices, right? So and these modules are adjustable. They can use to connect select line current. The initiating device sometimes can require or input, right? It is varies based upon different application that it can be used for, and provide relay function for activation and deactivation for critical system incorporated on the fire alarm panel. We extend the device numbers on the select line circuit on the panel as well as the number of notifier loop, right? So it may also use to monitor valves, flow switch, or pressure switch. The next thing we're going to look at is how one can arrange the network of the fire alarm panel. So fire alarm panels is network based upon the fact that we can increase its reliability in operation. And secondly, we must understand that a panel can work, each panel is worked independently. By networking the panel, we can reduce certain like inputs to the panel. So we're using one networking cable to actually drive the fire alarm panel. So in the case where you set up a fire alarm panel, it may requires like an external setup for each panel. But when we network the panels, then all the panels can be communicated externally, right? Without the use of rather to have communication between the central station and the whole fire alarm system, right? And then by networking, you can have all the panels being displayed in one area, right? So from a central display area, you're able to see all the different activities that is taking place by the notifiers, by the supervising modules, and all the devices on the network, right? So the networking providing such capability for better monitoring of the entire system and to have one setup for multiple panels where a central station can monitor all the panels, right? Without, say, considering an individual panel, right? In a independently set up. Next thing we're going to look at is the standard fire alarm. And as we mentioned, we have the input devices. That is on this side here where this is showing you the zone, which is zone 1, 2, 3, and 4. Then we have the notifiers, which shows 2 circuits on this side, right? And then this one provide relays output control as well, right? So we can set up relays, activate doors and fans and so forth. All right, so this is a standard fire alarm panel, so it looks. And then we have the input for the power, which is really on this side. And then we have like this side we have the AC, which is the DC is power source. In some cases this can be used to provide external power for other devices, right? And so forth. So this is just a standard layout of the fire alarm of a fire alarm system panel. Right, so when it comes to the select line current, that is the circuit that allows the input of all the initiating devices, right? So the select line current is the amount of current that is used up by the initiating devices, and that is based upon the number of devices, all right? And then the specific value for the device that is used on the input side of that initiating device, right? Or for the for the panel, they would have a certain amperature level. So the SLC for the input, it would have tells how much devices can go on it. So we can measure the total input value for the select line current for that for those for the amount of device can be placed on that particular circuit, and then that will determine the number. All right. And then now we have other stuff we may consider like losses that incurred by each loop. And that would factor in how many initiating device can be placed on a circuit. So the next thing we're going to talk about is the number of devices and the notification output. And that is simply, that is also the same because the notification has a certain output value in terms of the power that is capable of outputting, right? So based upon the number of notifiers, we might not have such capability to drive, all right, based upon the output value of the notification circuit. So the power consumption per devices is requires to be understood, and the power output from or fire alarm control panel, right? We may consider the line loss as well. Right, so the specific value of the notifiers is important to understand so that we can determine the number of notifiers on each circuits, right? And then we need to know the specification for the device, such as the voltage, the current, and the ampacity for the speakers and the strobes. So the next thing we're going to talk here about is the specification requirements that regards the devices. As we talked about earlier, understanding the current level for the device that we're going to use. So we use those to match numbers that we're going to place on each output circuits or input circuits. And then we're going to look at the output power that comes from each panels and the input voltage that is required, whether it want to be for the device or the whole system by itself, right? And further, we can look into what we call the alarm power, look at the battery backup connection. There's a lot of fire alarm panels come with emergency power source, just in case we lose power coming from the main. The number one issue when working fire alarm panel is that the power may be affected. All right, so the battery provide emergency backup. So there's reliable power source that provided to the control panel. All right, so that's just it. Guys, stay tuned for the next presentation. I'm very thankful again that opportunity to broadcast or to show you our first presentation, implementing a simplified alarm system. In our part two of our presentation, we'll be showing you how to program the device and the module, set up the parameter for the control panel, and the types of module we can utilize in implementing a fire alarm system and understanding supervisory, trouble, and alarm signal, right? And how we can also integrate other critical system with our fire alarm. Okay, guys, thank you. And I would like you to go and to subscribe right now to this platform and give us a like, and you may also share with a friend. Thanks.